Hey everyone, welcome back to the channel. I'm Nehemiah. I hope you're doing well. It could be a good evening, a good morning, a good afternoon, or maybe preparing to have a very good night at the time you're watching this video. I've been building a project for quite a long time, and I've faced many challenges and many successes. The company for which I'm not working for, but building this project for, like I told you in day one, has achieved massive success on ground and is growing. So what I'm doing is to share what can be publicly shared on the internet so that you can learn a few things from what I know and how I am going to prepare this project for a stage that could happen. And if it ever gets to that point, I will let you know on this channel. Okay, I hope I am audible. All right, I've just checked the audio is okay. So that's how I'm gonna be rolling on this channel soon. Yeah, it also gets interesting and gives me an opportunity to share what I know with you guys. And of course, like I always say, be open to learn from anybody. And because of that, if you have anything that you want to share with me, do not hesitate to open up and let me know. So over the past few videos in this playlist, I've been dealing with the DevOps and mainly Kubernetes Helm. I'm trying to set up the project in such a way that if I need to deploy using Kubernetes, then it can really help me do that. I want to get it ready for that. Also, it is helping me to not ferment. What's wrong with me? It's not ferment. This is what happens when you convert your local language to English, when you translate in your mind as you're speaking. I meant to say to cement, okay? I want to cement my understanding of Kubernetes. Many of you remember, I think maybe 6 or 5 months ago, I spent time learning Kubernetes live on this channel from their documentation. So this gives me an opportunity to cement it in my understanding. Okay. And I've had some good success stories from some of you who have been building this project. Okay. I talked to one of you, I think, just before this stream. I won't mention your name for privacy reasons. Even the other guy who talked to me last week on Saturday, you mentioned how you used DAFO or you're using DAFO to succeed. Okay. You've moved a step, you have DAFO flights in production working for you, and you're trying to see if you can launch a business out of it. And that is very, very great. Okay. I tell you to go on, encourage you to keep going on, and that you start doing the marketing. Okay. Yeah, you need real clients. For Airbound Ventures, the challenge is that the project already exists. Okay. But the challenge is having it in production. Okay. There are some documentations that took long. Okay. And instead I discovered that the payment gateway which I wanted to use wants 48 hours before they can do a settlement into the company bank account. So that's a challenge right there. I also want to tell you that the company actually operates and has clients. Okay, it has a physical location in Uganda, and clients go there literally every day. Yesterday, the business was dealing with China visas for 5 clients. So, China visas for 5 clients, and yeah, many clients came to consult about the ongoing restrictions of Ugandans traveling to Dubai and stuff like that. So it operates, and yeah, it's been busy on ground. But what we want is to have a platform that is working. Yeah, so that's, wait, something distracted me. Okay, it's okay. So that was said, or I said that to simply encourage you that people are applying this project in real life. They're applying skills from this project in real life, and it's adding to them. Okay. And yeah, it could help you. So let's deal with today's session. So today I want to go on to the next stage. Okay. And like you see the title of the video, it is as true as it is. So to avoid overriding the initial Terraform, okay? Remember we have main.tf, outputs.tf, terraform.tf that exists for this project, okay? I do not want to make changes to this because the current deployment on AWS depends on this, okay? Yeah, on AWS. I don't know what I said. Forgive me. I think I woke up on the wrong side of the bed, and what is it called? There's when your native language or your nativity fights against your tongue sometimes when you're speaking in another language, which is fine. So what I'm trying to say is that I'm not going to change this, okay? Because what we have here is the current deployment, okay? Using Compose. So I'm going to leave it, but I have here Kubernetes staging, okay? Which I want to be a staging environment, but will be an exact mirror, okay, one equivalent mirror of the production environment. As simple as that. So I will have, okay, a staging environment, a dev environment, and then a prod or production environment. And all these, my goal is to make sure that they are very equivalent so that I can replicate the production staging on the local environment. As simple as that. So I'll explain to you some of the things. Many of you remember when I learned Terraform in this playlist from scratch. And I hope this cements your understanding very, very deeply. All right, let's carry on. So first things first, I'll start from the terraform.tf file. Okay. So if you remember, when you're working with Terraform, the very first thing you need to do is to configure it. Tell Terraform what version you are using, okay? What version you are using. So according to this, I'm going to use version 1.10, okay? So it means use a version greater or equals to this. Let me expand this so that you can see. And this one is the minimum version, okay? This is the minimum version or the minimum required version. Then after that, you specify the required providers. Okay. So Terraform works in blocks. So you see we have a block here called the Terraform block. Okay. And when of course you're starting with Terraform, the first thing you have to ensure is that you have your Terraform block. And Terraform, think of it as a keyword. And then to open a block, use the curly brace, the opening curly brace, and a closing curly brace. So when you open it, okay, you have to set up your required version. And we are saying that the minimum required version is this. Okay, that's what the greater or equal sign means. Then after that, we have a block called required providers. Okay, so to create a block in Terraform, you simply have an opening brace and a closing brace. As simple as that. Okay, again, I'll start on line 2. We have the required version. This specifies the Terraform version. Then we have AWS as the required providers. Okay, so here we are saying that we are going to be using the infrastructure from AWS. What infrastructure or services are we going to use? Things like compute, AWS EC2. We can use cache like ElastiCache. We can use storage like AWS S3 or EKS, okay, for our Kubernetes. We can use ECR for our containers, or our images, as simple as that, okay? So we're saying the provider will be AWS, and the source of this provider will be from HashiCorp, AWS. Okay. The good news is that HashiCorp is the organization that creates or maintains Terraform for us, so we can trust this source. Then the version, it says that the version is between this version or less than 6.0. Okay, so less than 6.0, meaning that even a version of 5.100 can work. This is what this tilde greater than sign means. Okay, so I'll delete this. Yeah, so that's how we do when we want to set up the Terraform block. You simply specify the Terraform version, then you specify the required providers. Okay, for us, we have one provider, which is AWS, and the provider, the source where we're going to get the provider from is HashiCorp AWS. As simple as that. And this is the version we want. Then the backend simply refers to where you're going to store your state file. Okay, and our backend will be AWS S3, okay, in a bucket given this name. This is the name of the bucket, okay, and then key refers to the name of the file. Okay, so think of a bucket as like a folder, then inside that folder we have a file. So this would be the staging Kubernetes TF state. Okay, so that file is where we shall have the state. So state is simply a file where Terraform tracks changes in your infra, and it can store sensitive information. That is why you're not supposed to commit it to version control, and you're not supposed to expose it. Okay, so it's going to be in this state file in S3. Why did I choose S3? Because I wanted a public, not a public, but a central place on the internet in the cloud where the state file can be accessed, okay, from my local machine, from GitHub, from any other cloud environment or any other machine, okay? Having it on my computer will mean GitHub Actions does not have access to it, okay? And that is not good. So this is what we need, a global location where we can have GitHub Actions in our machine having access to the state. The region will be US East 2. Use log file is true. Why is log file true? Because I want to enable locking. Enabling locking will ensure that we don't have simultaneous edits or changes to the TF state file, which is good. Then we want to enable encryption on this file for security purposes. Okay, so that's the end of the Terraform block. Then we open the provider block called AWS. It simply configures that the provider, remember we have one provider in the required providers block called AWS, okay? And in this AWS block, we can configure this AWS provider, okay? And say that this provider here, okay, should have a particular region, okay? Of course, up here we said that for the backend, its region is US is 2. Great. That is for S3. But what about for AWS? What is the general, okay, region for AWS? You can configure that, okay, via an input and keep it changing, okay? So we are saying the provider called AWS, who has been configured right up here in the required providers block, their region is equals to var.aws region. So var.aws region is a variable that will keep changing. Okay, it can change according to the input, but it has a default value. That default value is stored in variables.tf. If I go right here to variables.tf at the top, you see, we say variable. Variable is a Terraform keyword. Okay, and the variable we are configuring is called AWS with a description saying AWS region for the staging Kubernetes platform, and it's a string, okay, and the default value is US is 2. Okay, so if, for example, maybe the region is US, maybe West or another region, okay, we can change it from the terminal. Okay, for example, if I type the command like You can say Terraform, okay, minus minus chdir to specify the directory, okay, equals to Terraform, okay. Do I want to type it out right now? / Kubernetes dash staging, okay. Then I can say minus minus var, okay. So var means an input you want to specify, okay. And we can say the var we want to change, we put quotes and say that the AWS underscore region is equals to maybe US West, I don't know, maybe 2, okay. I might be wrong about the actual value of the region, but this is how you override, okay. This is how you override. So we can have inputs whereby the region changes depending on what we want. So this gives us flexibility, which is quite good. All right. If you have any question, please leave it in the comment section. The other thing I want to talk about is this other directory, not directory, but file. Okay, we shall go to the variables.tf, and I had already touched on it. Okay, so variables.tf simply define inputs into Terraform. Okay, we have the AWS region. Okay, we have the project name, which is simply a short name for our infrastructure. Okay, it is a string and has a default value called hero backend. We have the variable environment, okay, which simply specifies the environment represented by Terraform. Okay, it is a string and its default value is staging. We have the GitHub repository, by default is this. Okay, this is good because in the event that I change the GitHub repository, then I can simply change it via the import, okay, without having to edit this. But this will be the default value. Then we have the namespace, which will be error staging. Later, if I want to do one for production, I can simply change using input, or maybe testing environment. I can simply change, okay, via the input to error staging. You get, so it makes it quite easy. So variables are simply inputs we can give to Terraform to change our configuration for maybe the Kubernetes namespace, the GitHub repository, the environment, the project name, the AWS region. And each of them have default values, which is a good thing. Okay, so think of variables as inputs, as simple as that. Then after variables.tf, I will go to main.tf. Okay, I want to go in a certain order. Okay, I thought of going in this order purposely. Okay, so main.tf. Okay, so in main.tf we have a number of blocks. Okay, we have what they call a data block, we have a locals block. Again, a block in Terraform is simply created by saying a block, okay, a block name. It could be a data block like we are seeing. It could be a variable block like we saw, or it could be a Terraform block, okay, a backend block, a provider block. It could be anything. So for this other one here, let me go back to main.tf. For the data block, we also do the same thing, give opening and closing curly braces. Now, what is this data block? Okay, because we're going to encounter it later. So it is best I define it now. Of course, people who have been following this channel and following this playlist know about this, but it won't hurt to reiterate just in case somebody who's watching this after the live stream sees it for the first time. So a data block simply is a read operation. Okay, it helps us to read data from an AWS resource. As simple as that. Okay, it does not create a resource. Okay, have that in your mind. Data is all about reading. Okay, finding out, reading. We don't create resources using data blocks. Once you have that, you've understood data blocks in Terraform. Okay, so you say data, what resource do we want to, what Terraform AWS resource do we want to read? It is the AWS VPC. Okay, and the default is the internal local name, okay, that we need, okay? So that later, if I want to refer to it, I'll say data, okay, which is this first one, then AWS VPC, which is this name here in quotes, okay, then dot default, as simple as that, okay? So data is a keyword, meaning we're creating a data block. Then AWS VPC is the AWS Terraform resource we want, okay? Then default is simply an internal name we can use, okay? As simple as that. And we are saying inside the block, we want to use the default AWS VPC, okay? So think of a VPC as, actually VPC in full is virtual private cloud. Think of it as your unique internet or network, global network within your AWS account, okay? That's the simplest form I can describe a VPC. Very soon I'm going to have a playlist covering AWS, okay? All the major things you need to know according AWS, and I'll go into VPCs in detail. But for now, think of a VPC as your virtual network, okay, within AWS, as simple as that. Then we have another data block. So again, whenever we talk about data block, know that we are not creating a resource. We're simply getting information, okay? We are reading, we are not creating a resource. So what do we want to find out or read from? It is the AWS subnets, okay? So think about a subnet as a subnetwork, okay? In your VIP, you have a VPC, which is a huge network within AWS. Then inside that network, you can subdivide networks, okay? You can have subdivided or smaller networks. That's what a subnet is, okay? And the subnet is, we're saying default. This is going to be, we want the default subnet. Okay, we're not saying we want the default subnet, sorry. Default simply means the name, okay? Think of it as a variable name we shall use internally, okay, in Terraform for locating it, okay? Yeah, as simple as that. That's my bad. So again, I'll repeat, data block, meaning we want to read, okay, a read operation, and we want to read from the AWS subnets, okay, we want to find out information about the subnets, and default is simply a local name we're going to use to refer to it. Meaning, if we want to make use of it elsewhere, we can say data dot AWS subnets dot default, okay, as simple as that. Now, when you look at inside the block, okay, inside the block, we have another filter block, okay, which says we want to filter by the VPC ID. Remember, up here, we have a VPC that we discovered, okay? Now, we want to find out subnets in that in a VPC, okay? But which VPC? Okay, we want to find out subnetworks in a VPC, but which VPC? Okay, that's the question that should be in your mind. Okay, we have a VPC from line 1 to line 3. Okay, then on line 5, we want subnets in a particular VPC. So we filter and say we want to filter by VPC IDs. Okay, then you see the values, because values is a list. You can pass a list of VPCs, but for us we have only one VPC. So we say we want data, referring to this one here on line 1, dot AWS VPC, the next, that's the resource name, then the local name, the local variable name we use in Terraform is default, okay? And on it, we can get properties, its properties. For example, it's ID. That's why you say dot ID, okay? So using this, we shall get subnets of this default VPC, okay? And it will be a list of subnets. And you're going to see later, we're going to have this, very important, okay? We are going to use this. So guys, if you're enjoying this video up now, whether you're watching it live or recorded, okay, and you think this is very useful, I ask you to like the video right now, okay? Like the video and share it, okay? So that YouTube can know that this is something awesome, it's an awesome playlist, and many people on YouTube can find it, or people in your networks can find it, so that we share and, yeah, learn together. So if I've said anything that you think maybe is inappropriate, please type it in the chat, okay? I would like to be interactive and learn from you as much as I share, okay? I don't think I know everything, okay? I'm a person who learns every day. I'm a daily student. All right. Next up, I hope you can see everything on the screen clearly. So after this data block, okay, that helps us to find subnets in a particular in a particular VPC, we now go to locals. Okay, and I'm going to explain what locals is. Locals is another type of block. Okay, again, an opening parenthesis and a closing parenthesis. A locals block helps you to do calculations, okay, of values, okay, but these values are for your internal use in Terraform, okay, only, okay. They don't accept inputs, okay. It's not like what we had here in variables.tf. No, in variables.tf you can have a input from the terminal, okay, and you can have a default value and you can change it. But for a locals, you cannot change its value from the terminal. You get. And with a variable, if you look at a variable, with a variable you cannot calculate, okay. You said you can have your default value here, and in the terminal you can pass a value to it, okay. But with a local, you can have a calculated value, but in a variable you cannot have a calculated value. What is an example of a calculated value? Look at line 13. Okay, on line 13 we have name. Okay, name is a calculated value. Okay, it says build a name from the var.project name dash var.environment. var.project name comes from variables.tf. If you go to variables.tf, you'll see we have project name and environment. So var refers to variable. Okay, that's how you to access a variable in Terraform, you say var, then dot to access the variable name, which is project name. Then this is a dash. Okay, so to have that value, or to get that value, you just simply do, so it's like this. You say name, okay, equals to, then you put a string, okay, quotes like that. Then to access a variable, you put a $sign and two curly braces. Then you say, I want a variable in the var object, in the var Terraform object, dot, maybe I can say AWS dash region. As simple as that. Okay, great. I'll remove this. So this is going to be the name, and this will be auto calculated according to the variables that we have. Okay, then we have a place called, not a place, but a block called common tags. For the common tags, we have the project, okay, which is the var.project name, okay, that comes from variables.tf. Go to variables.tf, okay, you'll see we have project name right here, okay. Then we have environment, which is var.environment, which comes from right here, this one, okay, default value is staging, okay. So then managed by Terraform. Okay. So these values don't change our infrastructure. They are simply informational. Okay. They are simply informational. As simple as that. And when you're doing like metrics, you want to doing analysis, okay, it is very good usually, or it makes it even easier, okay, to analyze your data, okay, by looking at things which have common tags, okay. Maybe you can group or look at analytics of particular projects in a particular environment and who is managing them, okay, and who's managing them rather, okay. And you can simply look at maybe like your AWS dashboard and know that, oh, this is being created by Terraform. So it is not a manual operation in the AWS web console. So for the project name, okay, by default, okay, project name value here, if you look at the value here, okay, it is error backend, okay. Then the environment is staging, which means the actual value will be error backend staging. As simple as that, okay. So if I go to the next line here, the name will be error backend, then the dash to have staging. As simple as that. Cool. I'll get rid of that. And I hope I've not broken anything. So I'll close this and go to another. That would be I'm thinking about ECR. Okay, let's go to ECR.tf. Okay, so ECR.tf is going to help us to create resources for our, what is it called? Our Elastic Container Registry. So Amazon Elastic Container Registry will be responsible for creating our registry that is going to store our images. Okay, so GitHub Actions will build our image, okay, and push it to ECR. Okay, then a node, Kubernetes node, will pull the image from ECR and then run the container. You understand? As simple as that. All right. Okay, so you see here we have two blocks, okay, two resource blocks. The first one here and the second one right here. This block called a resource block actually creates a resource in AWS. So if you want to create a resource, use resource. So resource is a keyword. If I open it, okay, it says AWS ECR policy. That's the AWS resource we are going to create. Okay, and then backend is simply the internal Terraform name we are going to use. So we can say resource dot AWS ECR repository dot backend. Okay, so this is going to create the Elastic Container Registry for us in AWS. I love Terraform. It makes life really easy. Okay, so the name will come from the var project name, from the variables I just showed you. Then you're saying image tag immutability equals to immutable, meaning that we want the tags, okay, of the images not to be changed. Okay, this will help us not to override particular images with particular tags. Okay, so that we can have many of these, okay, created at different points according to the git commit SHA, and okay, we can, okay, do, for example, rollbacks, okay, using a particular image, okay, because it is immutable, its tag is immutable, it will not be removed. Okay, we can go back in the past and be able to roll back or reproduce any deployment in the past. That is the advantage of line 3. Okay, so if you can't see my screen well, please let me know. That is something I should have mentioned earlier. I hope it is visible enough. Then after that, we have this block called the encryption configuration. Okay, simply says that we want to encrypt our data using a particular encryption algorithm, and that encryption algorithm is the AES256. Okay, so that our data is safe. So the image layers in ECR will be encrypted using that algorithm. Then it says image scanning configuration. It says scan on push equals to true. It simply means that our images will be it means our images will be scanned for vulnerabilities and issues. Okay, it will discuss them for us, but it does not delete an image. It does not fix the vulnerabilities for us on any issue. It simply scans, and if there's an issue, it tells us that your image has an issue, okay, which is a good thing. Then tags equals to local.common tags. Okay, this is what you saw in this other file. Where is it? Here. Okay, locals.common tags, which will simply tag the ECR by our project name, our environment, and say it is managed by Terraform. Okay, as simple as that. So I'll go back to ecr.tf. Awesome. Nice. Go to the next block. Resource AWS ECR lifecycle policy backend. Okay, so here we have a lifecycle policy which will be created, okay, for us. And if you look at the repository, it is referring to what we just created up here. It says AWS ECR repository.backend.name. Okay, and right here it has a name. So this is simply pointing to this, meaning that this lifecycle policy is for this particular repository. Okay, then we have here a policy being created. Okay, and that policy has a JSON encode. Why? Because policies must be in JSON format. And I don't want to suffer creating, okay, JSON right here, okay? It will be tedious, okay? So to avoid typing the JSON automatically, okay, we use JSON encode, and we simply write the usual Terraform format, okay? But JSON encode will convert the roles that we are writing in Terraform format into a proper JSON string, okay? So in the policy here, we put a number of roles, and for now we only have one role, okay? So I'll expand, and this one rule says rule priority equals to 1. And of course, it doesn't matter because it's only one rule. But if you had a number of rules, then this would take the first priority. And the description says keep the 30 newest images. As simple as that. Okay. So how does it select the images? Okay. So this is what the selection is all about. Okay. It says select images with a tag status. Okay. So any means that we want both tagged images and untagged images. Okay. And count type says image count more than. Okay. It means we're going to select, okay, and do selection according to a particular count. Okay. If the images are more than a particular count, then we do a deletion. Okay. We expire it. And this count type works with count number. So it says if the image count is more than 30, okay, if there's lasted, or its life cycle, or its lifetime is more than 30, then we perform a particular action on line 27 and say that the type is going to expire. We expire it. Okay. So any image that lives up to its 31st day will be expired. That is what this lifecycle policy simply means. Okay. And this is how you deal with them. Once you understand the concepts, these things are very easy. Okay. Like you're seeing. Okay. So I'm done with ECR. Okay. So in ECR, we're simply creating a repository to store our images. And that is where our nodes are going to pull the image from. Okay. And we are creating a policy to simply define how long those images can last in ECR. Okay. So ECR will have our images encrypted, okay, scanned with immutable tags, okay, and we shall have the 30 newest images being kept, okay. Every 31st image, okay, will be expired. As simple as that. Now I will go on to the next one. I'll go to redis.tf. Okay. Yeah. Well, let me see the time. Just make sure I'm not cut out. So if you're enjoying this, whether you're watching it live or after the live stream, yeah, hit that like button and share. Okay, so right here in redis.tf, there are again 3 resources. Okay, 3 resources. You get, we have the AWS security group, AWS ElastiCache subnet group, and AWS cache replication group. Okay, so I'll start from the top here. Okay, in AWS, you need a firewall, okay, to protect incoming traffic. Think of a security group as a firewall. As simple as that. A security group is a firewall, and that's what you simply need to know. So we're creating a firewall for our Redis, okay, in ElastiCache. So it's what we define up here, and we shall refer it as resource.aws security group.redis. Okay, it has a name, and that name will take local.name from the locals I explained a few minutes ago, and dash redis. Okay, description simply says allow redis traffic from the EKS cluster. And that's the goal of this. Okay, we want traffic only from the EKS cluster. It has a VPC ID, okay, saying data redis.aws_vpc.default.id. Okay, this is connecting us to the VPC we have here. Okay, I think it's VPC here. So data.vpc.default is referring to data.aws_vpc.default. As simple as that. Okay, and this is good because because these tools are going to communicate, they have to be in the same network, okay, or in the same VPC for proper communication. Okay, so this security group is going to work for us in that VPC. Then you have ingress, okay, which simply refers to incoming traffic, okay, into our Redis, okay, and these are rules that are going to apply to it. Description says Redis from EKS, okay. Then we have the port range, okay. So you're saying we are going to allow ports from port 639 to 639, okay. So because it's the same, the to port and the from port is the same value, then it means you're only allowing one port, which is port 639. Then we have the protocol, which is TCP. Okay, so the network request must occur over TCP. Meaning, when you're sending a Redis request, you must do something like this. You must say Redis // Okay, I don't know whether it's a single S or a double S. Okay, yeah, but it should be like this. Meaning you're sending requests over TCP. If you don't, it will fail. Then we have your security groups, okay, which is simply a list, okay, of security groups, okay, where we expect traffic to come from, okay. And this talks about this is saying we're going to expect it from the AWS EKS cluster, okay. I'm going to show you this EKS cluster soon, okay. .staging, okay. .vpc config, we pick the first one, which will be the only one and the default one. .cluster security group ID. Okay, so I'll explain this. This simply means that we are wanting to associate the Redis traffic only from our EKS cluster. So EKS is the Elastic Kubernetes service, okay, if I've said it in full correctly. Okay, but it's simply a service where that manages Kubernetes for us. It will give us a Kubernetes control plane. And we are saying that the requests, okay, for Redis should come from the EKS cluster. That is all. Okay, awesome. Now the tags, okay, tags equals to local.common tags. You get. So you see that our resources are being given the same tags. That when you're doing analytics later or trying to trace something, we look for those common tags. So that's our firewall or security group defined. Then we have the AWS ElastiCache subnet group, okay? And we have the staging as the local name given to it internally here. So we say, what is this? So we say resource.aws elastic subnet group.staging to refer to it, okay? And it has a name whose name is built from the local.name, then a dash Redis. And then we have subnet IDs, which is equals to data.aws subnets.defaults.ids. Okay, so here this is like a placement. Okay, we are telling the ElastiCache subnet group, okay, that here are the available subnets you can use. Okay, and remember, these subnets are coming from what we defined earlier. Okay, right here, data.aws subnets.default. Okay, so we're telling you it's like a placement saying if you need subnets, if you want to place, if you want to create an ElastiCache subnet group, use the following available subnets. Okay, and we say we provide the subnet IDs, and AWS will do its magic for us. I'll close that. Then we go to the actual AWS. I mean, not the actual AWS, but the actual ElastiCache or the Redis. Okay, so it is a resource, meaning it will be created, and the resource name is the AWS ElastiCache replication group. Okay, and the internal name we shall use to refer to it will be staging. So it is called a replication group because ElastiCache can have a primary node, okay, and can have replicas, okay. As simple as that. That's why it is called a group. You can have at least one or more than one. That's why it's called a replication group. Okay, so the name can be a little bit misleading, but yeah, I hope now you understand from what I've just explained. But for staging environment, you shall only have one. Okay, why? To keep costs down. Then we shall say replication group ID, okay, will be built from the local.name, then dash Redis. Description simply says Redis for the staging backend. Okay. The engine, of course, is Redis. Wanted to choose Redis as our cache, and this is the version we want. And the node type is a cache.tg. Not what's wrong with me? I'm almost biting my tongue. The node type is cache.tg. What am I saying? Why do I keep saying tg? It is cache.t4g.micro. Okay, yeah, t4g.micro. It's a small machine with small resources. Okay, little. Is it little or small? What do you say? Small memory. Okay, small resources. And for staging, this is enough. Of course, in production, you might want a bigger machine. So this is the name of a machine, an Amazon machine image that can have little enough resources like memory that can help us run Redis. Then the port, of course, is 6379, which is the default. Number of cache clusters is 1. This is staging, okay? But in production, you can have 2, okay? Says subnet group name, okay? Will be this one here, up here. Are you seeing this? AWS ElastiCache subnet group .staging .name. So this is referring to the resource on line 18, okay? So that's the subnet group name. Says security group IDs, okay? We can give it a list of security group IDs, okay? For us, we have only one, which is AWS security group.redis.id, and it is defined right up here, okay, on line 1. After that, we have says at rest encryption enabled equals to true. Simply means after our data has been created on the node, please encrypt it. Then says transit encryption enabled equals to true. Simply means the request. Okay, transit means when something is happening. When the request is occurring, please, we need an encrypted communication. It says automatic failover enabled equals to false. Why false? Because we have only one cluster. Okay, we have only one node, okay, in the cluster. So there's no need to have failover. Okay, for failover to work, you need at least 2. Okay, so that when one dies, another can replace it. Okay, it says multi-AZ enable equals to false. So this is for having multiple zones. Okay, but in our case, we're only going to have one. Okay, we don't have a multi-zone setup. Okay, when it's needed, then we can do it. Okay, it says apply immediately true. So it means that as soon as we get a request for the what is it called? The ElastiCache to be created, apply the changes immediately, create it immediately, okay? But be careful with this, okay? It can create for you certain issues, especially if the changes are going to be breaking, okay? Yeah, but this is staging, so it can be applied immediately. Says snapshot retention limit, okay? So we can have backups, okay, being created for us, okay? And these are the snapshots. But this simply tells how can I say how long it can be retained. Okay, can be retained. That's the backup. So we're just setting it to 1 for production. Okay, then again we're attaching the same tags. Okay, so we have the same tags right here. Even here the same tags. Okay, not oh yeah, even here. Okay, yeah. So we have our firewall. Okay, we have the subnet group and the actual Redis replication group. And for us, of course, we only have one. It's called a group, but we have only one, meaning you can have one or more. All right. Well, I've spoken for long. The next one I need us to look at is the EKS.tf. Yeah, we're almost down. We're almost there. We're almost there. EKS.tf. And like you see, these concepts repeat, okay? They repeat, and you're going to find them very easy. Even here, we are creating a number of resources. Now, here you see we have a number of blocks, okay? We have a locals block, we have a data block, we have a resource block, another resource, data, resource, okay? And I'm going to explain this in a minute. And I think I need to stand. So it's give me a minute and to adjust my setup briefly. Let me try to stand. Maybe sip some water. Let me get back in a second. All right, I'm back. I don't know if this thing is okay. I think now it's, yeah, you can see me the right way. Okay, let's continue. Let me just adjust my mic so that I can pick you up and make sure everything is working as expected. I just wanted to stand to make sure I don't overwork my back. All right, now to understand what is going on here, okay, I need to touch on something that you may know or you may not know. Okay, for those who don't know, you will have an idea of it from what I'm going to say. For those who have never, have done it, okay, it will just be like a reminder, okay. AWS has something called AWS IAM, okay. I for identity, A is for access, M is for management. So identity and access management, okay. Some people pronounce it as IAM, okay. So I'll call it AWS IAM. AWS IAM simply helps us, and it's very powerful in AWS, simply helps us to know who a person is, okay, or what an identity is, okay, and what they're allowed to do. An identity can be, for example, like maybe normal users, okay. It could be maybe your GitHub. It is simply anything that is asking to use an infrastructure, a service on AWS. And in our case, okay, GitHub Actions is going to be an identity. My laptop here is going to be an identity, or me, okay, when I do help on my laptop, okay. So when you are dealing with AWS, okay, you need to create an identity, and these identities need to assume a particular role, okay, and this role is is simply created to answer a question: who can perform something, okay. That's what the role is. And once this role is created, it needs something else called a trust policy. Okay? So this trust policy answers a question, which is who is allowed to assume a role. Okay. So to assume a particular role, okay, you need a trust policy. As simple as that. So a trust policy gives you the initial access. So when you have this initial access, you need another thing called permission, okay, a policy permission, which means you're going to be given fine-grained allowance or permissions to perform particular actions, okay. So you create which means you create a role, okay. After creating a role, you create a trust policy. A role needs a trust policy, and you need a permission policy. So a role in AWS, okay, needs a trust policy and permissions, okay. So the trust policy allows an entity or an identity to assume a role, okay. After you've assumed the role, then you need now permission to do particular actions, okay. And those particular actions are given to you by permission policies. So I'm explaining that because I'm going to show you in this EKS.tf. So EKS.tf will help us with creating the Elastic Kubernetes stuff, okay, service. All right, so we have a locus block up here, okay? And locus block simply has data, okay? The first one is a set of EKS cluster policy ARNs, okay? ARN is Amazon resource name, okay? Which is simply a unique string which points to a resource on AWS. You get. Then we have another setup up here, which is for a number of ARNs, okay? The first ARNs up here are for the EKS cluster, okay? The other ones down here for the node, okay? So we're going to give permission to the cluster, to the EKS Auto Mode to do particular things, okay? Then we shall also give permissions to the actual nodes, okay, to do particular things. So for the first set here, we have, before even that, why am I saying to set? To set will simply, of course, a set gives you data that is not having duplicates, but the whole purpose is to help us to do a for each operation. You're going to see that a for each operation very soon. Okay, so we have a number of ARNs. We have one for storage, okay, to enable us create storage, to enable the EKS Auto Mode to create storage, okay. One for general cluster management, one for compute, one for load balancing, and one for networking. Okay, so those are very important. Then we have one for the nodes. Okay, the nodes will need to pull images. So you're seeing Amazon container registry pull only. Okay, and also they need to act as EKS worker nodes. So the EC2 machines need to work as EKS nodes. That's why we have the Amazon EKS worker node minimal policy. Okay, awesome. So I'll close this, then close this. We can close all of them. Okay, so those are our errands. Okay, and this is not guessed. This is how they actually are on Amazon. And if you Google the Amazon docs, you'll see that. Nice. So I'll go to the next one, which is this block. It says data. Okay, by now you know what a data block is all about, and it's called AWS IAM policy document. Okay, EKS cluster assume role. Okay, so this is going to be a policy document that we are creating. Okay, if I open it, you'll see it has a statement. Okay, so this block creates a policy statement. Okay, and it has the actions and principles. Okay, let me explain this. It simply says, okay, we want to allow a particular service. Okay, type equals to service says we want to allow a particular service. Which service is that? Okay, to know the service, we go to the identifiers. Okay, this identifiers list has a list of services. We say we want this service, this EKS service, okay, to assume a role, okay, and be able to also put tags. As simple as that. We want this service to perform these actions, okay? So STS is a token service for AWS. As simple as that, okay? So this is the policy document we create. So we are saying that the EKS service will be allowed to assume a role. Okay, so this is the trust policy. Do you understand that? This is where we are saying EKS service is going to be allowed to assume a particular role. Now, which role are they going to assume? We are going to assume the role on line 27, the AWS IAM role, okay, for the EKS cluster. Okay, so if I open it here, okay, you see the name is bit from local.name cluster, the assume role policy. Remember, I told you a role needs to assume a policy, and that refers to, I think, data.aws IAM policy document .eks cluster assume role.json. Okay, is referring to line 16. As simple as that. And line 16, like I told you, this statement will give us a JSON document. Okay, but it's a data block. It will give us a policy document, which is a JSON document. So we're giving a role its policy, saying EKS is allowed to assume this particular role. That is how AWS IAM works. Then we go to the AWS IAM policy attachment. Okay, so we're attaching the individual permissions now. Okay, remember you've created the role, you've created the trust policy. Then now you need the individual fine-grained permissions to be given. Otherwise, without it, you'll have access, but you cannot do anything. Remember, I told you IAM is all about who are you. So this first part here, okay, helps us to know who you are, that we trust you. Okay. Okay, after we trust you, what are you allowed to do? Okay, this is where now the AWS IAM policy attachment works. Okay, what you're allowed to do. Okay, this now give you what you're allowed to do. You're allowed to do the following. Okay, we have here for each loop. Okay, it says local.eks cluster policy RNs. Okay, what you're allowed to do is define up here. Say we have locals.eks cluster policy ERNs. Okay, so meaning EKS Auto Mode will be able to request for block storage, do cluster general work, create compute, meaning creating nodes, do load balancing if it wants, manage networking for the cluster. Okay, so for every policy document there, every permission there, okay, we set the role, the current role, which is AWS IAM role, this one up here, okay, .eks cluster.name, meaning this one role, okay, will have every policy or every permission. So it says, that's why we're saying policy RN is equals to each.value. So each refers to every value in the for each loop. Isn't Terraform amazing? Okay, and very, very simple. That is how it's going to work. So I'll close this. So that's the general flow. Okay, create a role. Okay, create a policy, give the role its policy, its trust policy, then give the fine-grained permission policies to the role. Okay, as simple as that. Then when we come down here, we have a repetition of the same. Okay, so we have done it for the EKS cluster. Now we also need to do it for the EKS node. We need to stretch a little bit. So for the EKS node, we also build a trust policy document the same way. Okay, we are saying a type, a service, okay, a principal whose type is a service, okay, but which service is that? Will be the EC2, because remember our nodes are going to be EC2 machines, okay. This EC2 machine, okay, the EC2 service will assume a particular role, okay. So we are creating our JSON policy, okay. So this is going to be JSON policy, and this JSON policy, okay, will be used down here in the IAM role, okay, by saying assume policy is data, referring to data on line 40, AWS IAM policy document, which is the next text on line 40, then .eks node assume role, which is this text on line 40, .json. You get as simple as that, okay? Then the tags, we give it the common tags. Remember, all our resources are having these common tags. It will help us in finding them and doing analysis. Okay, this is cool. So our role has its trust policy. Okay, we are saying allow EC2 to assume this role. What allows EC2 to assume a role as a EKS worker node is the trust policy, which we created line 40. Then we go to 57. Okay, says resource, AWS IAM role policy attachment, EKS node. Okay, now we are giving the role the fine-grained permissions. So for every fine-grained permission, this is a for each loop. Say local.eks node policy ARNs. That is up here in the locals, EKS node policy RNs. What are those fine-grained permissions? The first one is to pull images from ECR, okay, and also to work as an EKS worker node. As simple as that. Okay, so we attach them here. So the role is this role on line 51, AWS IAM role dot EKS node dot name, referring to this whole line, then line 52. As simple as that. Okay, and the policy RN will be every value, okay, we get from the for each loop. So each simplifies to the current value in the for each loop dot value. As simple as that. Okay, so now you have the two. You have the policy. Okay, you have a node. I mean, not a node, but a role. Okay, having its trust policy and its policy permissions or the actual permissions. And we have done that for the EKS, okay, and the EKS node. The EKS cluster and the EKS node. Then you have the final big guy here called the AWS EKS cluster. Okay, that is when now we do the final things. Okay, the cluster, this is the cluster's name. Okay, the role, okay, it is up. It's called AWS IAM role or EKS cluster dot ARN, which is simply up here. Okay, sometimes when you're doing this field, you can even just search. Okay, you search for this. Okay, you'll find it up here. Okay, so if I go up, it's referring to this on line 27. Okay, so just commenting, connecting it. Okay, that the role for the EKS cluster is this role, and remember that role, what we defined up, needs a trust policy and permissions which we defined. So this is the role. This is role. Okay, it's trust policy and its permissions. As simple as that. Okay, then access config says authentication mode is equals to API. Okay, simply says use the EKS access entries for cluster authentication. As simple as that. Then says bootstrap cluster creator admin permissions equals to true. This simply gives the identity, okay, which is going to be that is going to do Terraform apply, okay, which will be our GitHub Actions, okay, doing the Helm command. Okay, so that identity, okay, that is going to apply everything, okay, is given initial admin access. Without it, it can have access but not be able to perform what we want it to do. Then compute config, okay, simply means on line 74 we're enabling EKS Auto Mode, and EKS Auto Mode will be able, using this role it has, to manage block storage, compute, okay, load balancing and networking. All right, so node pools are simply rules. Think of them as rules for creating nodes. Okay, and we have general purpose and system. So general purpose simply means nodes to handle application workloads, like our fast API backend. Then system simply means Kubernetes specific tasks. Okay, nodes for Kubernetes specific tasks. Then a node role ARN, okay, would be simply this. Okay, AWS IAM role dot EKS node dot ARN. Okay, because those nodes need particular permissions, like for example, pulling images. Okay, and acting as EKS nodes. So this is what we created above. Where is it? This one here on line 51. Simple as that. Then we go on to network config. Okay, this is simply to enable load balancing. This one is to enable block storage. As simple as that. Then the VPC config. Okay, simply means endpoint private access. It means we need to enable communication for the API, but this is the Kubernetes API, not our application API. Okay, enable Kubernetes API communication internally. Then endpoint public access simply means we want access externally, like from our laptop, from Kubernetes. Okay, not from Kubernetes, I mean from GitHub Actions. Okay, to Kubernetes from our laptop using Helm to Kubernetes. Okay, as simple as that. But it does not mean you don't need authentication. You still need authentication. Starbit IDs. Okay, so this is simply saying these are the available subnet IDs to use. Okay, and this comes from main.tf. So data.aws subnets default.ids, okay, refers to this line here, line 5, which I first tackled earlier. Okay, then we have the common tags. Okay, then we have dependencies, which simply means that we must have the policies for the cluster created. Then you should have the EKS node policy attachment also done. Meaning we need the role, the trust policy, and the permissions created before the cluster. We don't want to have a situation whereby you have a cluster but no role, no trust policy, no permission. Okay, so this ensures that they are created first before the cluster. Then you have a lifecycle precondition. Lifecycle.precondition, the condition simply saying that we need at least 2 subnets to be created. Okay, if this is not met, okay, if the subnets are not greater or more than, are not 2 or more, okay, then Terraform will fail and we shall have this error message being displayed that EKS requires at least 2 default VPC subnets in different availability, something like that. Okay, yeah, wow, that was a lot. So wrapping up, this needs you to have a long constitution span to understand the things. So we need EKS. I've done GitHub Actions. Okay, let's go on to GitHub Actions. So the same concept applies. Okay, we need GitHub Actions now. This is now handling GitHub Actions to allow GitHub Actions. Okay, do what it wants to do. Okay, for example, like what am I even saying? I guess my mind is tired. I'm trying to say that this is going to be responsible for allowing GitHub Actions, okay, assume a particular role, okay, and be able to have the permissions to do that role, okay. So on the first line here, we have data, AWS caller identity, current, okay, and it's empty, but simply says, give us the ID or give us the current AWS account which is connected, okay, which should be mine or yours, okay, according to your credentials. If you don't know how to connect, by the way, check out in the playlist. We have a playlist where I showed you how to connect. Okay, when I was dealing with Terraform. Okay, then we have another locals here, and we simply have the GitHub OIDC provider ARN. Okay, so you know what an ARN is, and if you don't know what OIDC is, please check out the Open Connect video in this playlist where I talk about it. Okay, it simply helps you to authenticate with, it helps GitHub to authenticate with AWS without using permanent secrets. Okay, like maybe your password or an access key or an access secret key. Okay, it avoids that. So what happens is that GitHub creates this token, okay, that is sent to AWS, and AWS says, okay, I can prove that you are who you are. Okay, and AWS gives GitHub a token to use temporarily for only that period, and after that, it's done. Yeah. So here we're simply building the ARN for that. Okay. Yeah. So you see it uses particular values like data.aws caller identity.current.account ID, which is referring to this. Okay. This whole line 1.id. Okay. Line 1.id. Okay. Then you see the provider, okay, is referring to token.actions.github user content.com. Okay. As simple as that. Yeah, so this is, if you find it, it's actually, this is how you define it according to the GitHub documentation, even AWS documentation. So we now continue. So we have here data, another data block, okay? And this data block is going to be responsible for us having another policy document. So you see, it says AWS IAM policy document, okay? And we shall refer it as GitHub Actions Assume Role. So when I open here, you see, it says federated, okay? And this is the role we want to assume role with web identity. Now, web identity is one that you configure. Actually, those who watched the video, the OI, this is the OIDC, the Open Connect video, okay, in this playlist. You see that when I went to AWS console, I chose the web identity. Okay, so the principles, like I've said, okay, earlier, it has two things. Okay, it has the type, which says federated. Now, federated simply means it is an external entity. Okay, it's an external entity. Okay, those which are not federated are things like EKS, because it is within AWS. Okay, Redis, ElastiCache is within. Okay, maybe S3 is within. Okay, but federated means something outside. Okay, and for our case, it is GitHub or GitHub Actions to be precise. Okay, so it will be a web identity. Okay, so the identifier says local.github or OIDC provider, ARN, which is what I explained to you right here. So it will say that this provider here, okay, this GitHub Actions, okay, which is an external entity or federated, okay, has been given opportunity to assume, okay, the web identity role. You get as simple as that. Then we go into the next one. So it's resource. This is the IAM role. Okay, the IAM role. And this IAM role, remember, I told you an IAM role needs to assume a policy, meaning GitHub Actions needs to be given permission to assume a policy. A role must assume, okay? That's why you see on line 35 says assume role policy. Okay, then it says data.aws assume policy document.github actions assume role.json. Okay, as simple as that. Okay, and it's simply referring to this. If you look at all this, if I select all this part up to here, okay, is referring to all this other part on line 7. Okay, then .json. Why? Because this statement here, okay, creates a JSON file for us. Okay, creates JSON for us. And again, we are giving our resources the same tags so that we can easily find them on AWS. Okay, nice. Now we continue. I'll close this. Okay. In fact, let me just open these other ones. Okay, let me just open the next one. Okay, the next one is also another AWS IAM policy document. So you see that I've been repeating these concepts again and again. Okay, how do you master these things, guys? By repeating again and again and again and again and again and again and again. That is how you achieve mastery. Okay, so we have another statement here. Okay, mini statement. Okay, with an ID, it says authenticate to ECR. I think it speaks for itself. Okay, and the action is the get authorization token. Okay, and resources is saying star asterisk, meaning all. Now, this could be dangerous. Okay, but why it is star is because AWS does not have support for being specific in this case. Okay, so it requires you to put this. Okay, but this star, okay, only applies to the get authorization token. Okay, don't misunderstand it. Okay, it is saying wildcard, okay, but only to the get authorization token. Okay, to enable us get an authorization token, we need all. Okay, as simple as that. So this wildcard, I don't think it refers to everything. No, it only refers to the get authorization token. Okay, from ECR. Because remember, GitHub Actions, okay, needs to push an image to ECR. But to push a token, not push a token, sorry, to push an image to ECR, you need, okay, you need to be authenticated. Okay, and for authentication to happen, you need a token. You get. So this wildcard, again, I repeat, only applies to get authorization token. That is all. So that's the part of the policy statement. Then we have here the push and read backend images. Okay, so before you push and read backend images, you need first authenticate. Guys, does it make sense? Okay, I think now you see the logical order. Authenticate, know who I am, then I can do what I'm allowed to, what I can do. Okay, like I told you, IAM is all about who are you and what are you allowed to do. So when you think about AWS IAM, answer that question in your mind. Okay, who is going to do what, and who are they? Okay, and what are they allowed to do? Okay, before you know what someone is allowed to do, know who they are. Okay. All right, so we shall continue. So push and read images comes with particular actions. Okay, we have the batch check layer availability. Okay, batch get image, complete layer upload, get download URL for layer, initiate layer upload, put image, upload layer part. So all these actions simply, number one, help us to have access to the image layers. Okay, and these image layers, like we have seen, are going to be encrypted. Okay, and it can help us to push an image to ECR and get information about it. Okay, like know the what, the download URL. You get as simple as that. Then we have the resources, and it's a list. Okay, it says is AWS ECR repository.backend.arn. Okay, simply saying these actions are going to only happen with a particular ECR repository, which is defined right here. Okay, as simple as that. So when we go down, we have another statement. Okay, it says describe staging cluster. Okay, it says the action is describe cluster. Okay, and the resources says AWS EKS cluster.staging.arn. Now this simply means that we want to allow, we want to create a trust policy, a kind of trust whereby GitHub Actions can describe cluster. What does describe cluster mean? It simply means that we are allowed to get information about the EKS cluster, for example, know about the Kubernetes API so that we can send requests to it, so that we can create Helm commands, okay? Or we can do kubectl, or we can ask for permissions, okay, for other admins, as simple as that, okay? So describe cluster simply means we want to get information, for example, like the Kubernetes API, the EKS endpoint, so that we can perform operations or communicate or make requests to it, as simple as that. So yeah, so GitHub Actions needs ECR for the image, okay, and needs also EKS. And if you look at this, you see the resources. You have to tie to a particular node. Of course, it's a list, but for us we have only one, and that's enough. Let me close this. Next, so that this was a data, okay. So we are creating a document. So we have a resource called the not IAM, but AWS IAM role policy. Okay, the name will be from local.name, then dash deploy. Okay, then the role, okay, is called the AWS IAM, okay, role.github actions deploy.id. So AWS IAM role, where is it? It's right here on line 33. You get very simple. IAM role GitHub actions deploy.id. Okay, what is the policy? It is the data, okay, dot AWS document, AWS IAM policy document, dot GitHub actions deploy, dot JSON. What we defined just up here on line 39. So we have a role and its policy. Like I've been saying over and over again. You get a role and a policy. A role and a policy. A role defines who can perform a work, and a policy defines who can be trusted to do that. So if you define a role without a policy, it will not work. Okay, AWS needs you to say that so and so can be trusted to perform this role. Okay, and that is by the policy. Go to the next one. AWS EKS access entry. Okay, is the resource we are creating, and we shall refer to it as GitHub Actions Deploy. Yes, internally. Okay, so the cluster name will be the EKS cluster.staging.name. Okay, we created it up here. The cluster was created up here. Sorry, not here, but actually in the EKS file. You remember here in EKS, okay, we created it. So the policy RN, okay, is AWS IAM role, okay, AWS IAM role, this one, dot GitHub Actions deploy dot ARN or Amazon resource name, this one here, okay. Then the type is simply standard. So this gives you access. This resource is saying, give us access to EKS. Now, to have access to EKS, you need a role, this role that we're referring to, okay? And for that role to work, it needs a policy, which we defined up here, okay? So for EKS access entry to work, we create a role. In that role, we give it a policy. And the policy simply says, trust this guy to have access. Then, if you stop here, you'll have access, but you'll not be able to do anything. So to be able to actually do something, we need the AWS EKS access policy association. So the access policy association, okay, inside here in this block, again, has the cluster name. If you look up here, okay, I think cluster name on line 80 and cluster name on line 74 is the same value. Okay, that should click something in your mind. Why are they the same? We're working the same value. We need access to the same cluster. We need policies or permission policies or fine-grained permissions or fine-grained actions to do in the same cluster. So the name has to be the same, okay? It does not confuse you. So again, the first one is to help us get in, okay? But when you get in, you can stay there and do nothing. To be able to do something, you need line 79, okay? So we have the name, we have the policy RN, okay? You see, look at the policy RN. It says AWS role.github actions.deploy.rn, okay? So here we shall get the actual, I mean, not this is not the policy RN, but the principal RN, sorry, okay? Even up here on 975, it was the principal RN, okay? So we have a particular policy RN that we add on line 82, okay? Which is the edit policy, okay? It will help us to perform changes, okay? We need to have the edit policy. So I add it on line 82. Then the access scope, it says type namespace. You're saying we are restricting this to a particular namespace, okay? And this namespace is called, or is one of the namespaces in this list of namespaces. You can give a list of namespaces, but in our case, we only have one namespace, which is var.kubernetes namespace, which is in the file I explained at the beginning, okay? Okay, Kubernetes namespace, which will be error staging, okay? So this is going to be restricted to the staging environment, okay? You can copy and paste this configuration and make it work for your production environment, for your testing environment, for your development environment. Concepts are 100% the same. You get what changes is simply you copying and pasting things. You can even tell AI to edit things for you. Okay, but of course, don't forget to review. Review it, make sure it is perfect, and apply it. Then finally, we need one more file. Okay. The last but not least is the outputs.tf, which is very obvious. Okay, outputs.tf, like we saw many months ago when we were dealing with Terraform, is simply values that you get from Terraform after everything has successfully worked out. Okay, we have the output is the keyword, and so these are output blocks. Okay, so we have the EKS cluster name, okay, which will be go from the AWS EKS cluster.staging.name. Okay, AWS EKS cluster will come from the EKS.tf file, okay, that we defined. Output ECR repository URL. We just need to look at it, okay, where our images are being stored. Okay, Redis primary endpoint. This is where our ElastiCache. Okay, you simply get the primary endpoint address. Okay, and of course you'll only have one primary node. There is no replication being handled. Then we have the GitHub Actions deploy role ARN. Okay, as simple as that. So these are just outputs, values we shall get after everything has successfully worked out. Now, I know this has been long, but let us perform some commands to verify this. Okay, to verify this. So I'll open up here, clear my terminal. Okay, and let's start. So the first command you do, you need to validate your stuff. Okay, So I'll say Terraform minus, is this one minus or two minuses? We shall find out. CHDIR. Okay, this tells us tells Terraform where your config is located, and first it's in Terraform / Kubernetes dash staging. Okay, then we do init to initialize. Okay, so it says initializing backend. Okay, initializing provider plugins. Okay, because I've done it many times, it's saying reusing version of HashiCorp AWS. Okay, using previously installed HashiCorp version. Okay, it says Terraform has been successfully initialized. You may now begin working with Terraform. Okay, let me not read all of this. So if you go here, there's a file I forgot to tell you. I think this Terraform log file, okay, it was created automatically for us by Terraform, okay, and you can see the version it locked at was 5.1, okay, yeah. So don't edit this file, guys, okay, leave it, let Terraform do its thing. You're not supposed to edit it. Then ensure you ignore your Terraform state file, okay? You'll see that when I push to GitHub. Then after that, we can do the same command, but we think with a minus fmt minus check. I hope I put the command right. No, I think that is wrong. Okay. Is there? I want to check the format. Oh, yeah, everything is okay. Yeah, that minus is not supposed to be there. Then I can do the validate just to find out if there are any structural issues. Okay. Validate. Let's wait and see. So you see, say success. Configuration is valid. Okay. Yeah. This just adds to your confidence that things are okay. So next up, then I'll do finally plan. So plan will give us a peek, okay, of what is going to happen. Okay. What is going to be applied, how it will look like. Okay. If it's not available, then it will us this will be only available after you have deployed. Okay. So you can see, okay, you can read through it. I don't go through all it because we have just spent the last 1.5 hours discussing everything, okay? But you can look at it in your free time. After that, you can do the apply command, but I'm not going to do this, okay? I shall leave GitHub to do its things for us, okay? And of course, if you do it, just know you're going to be charged. So if you do it, make sure you bring it down immediately. All right, see you in the next live stream or video. This has been a long one, but very beneficial. Hope you've learned a lot. Like the video, share it, subscribe, and I'll see you next time. Bye for now.